So let's look at a case where you need to revolve about the y-axis. In this case, it's not the x-axis again. So how do we go about such situations, right? So we also have functions like this. The first example that we did it was pretty easy, right? So I decided not to bring just one function, but I decided to use two functions so that you can develop a solid understanding of this part of the tutorial. So let's quickly look at how we can do that. It's follow the same approach, right? So as I was telling you, first of all, get out the important information that you need. So when you look at this question, right, the difference between this question and the previous question that we did is that, first of all, the previous question we were revolving about what the x-axis, but for this one we are revolving about the y-axis. And when you also look at the previous question, we were given the limits or the limits of integration, right? But for this part, we have not been given the limit of integration. So you have to pass through the process that I showed you in my previous tutorial to be able to get the limits of integration. And from there, that will be your limit of integration, whereby you have to integrate over to get a volume of revolution, right? So quickly, this is what I was saying. First of all, get out the functions and then try and then do a hand sketch of this function. Some students may be lucky to have some TI calculator or any other graphing calculator that they can use to sketch the function to get what they want. But to us, those who don't have calculators, right, or graphing calculators with us, what we can do is to kind of get a small sketch by hand and then use it for our calculation. So let's go ahead. So the first function that we have here, it's y equal to the cubic root, right, of x. And then, as I was telling you earlier on, I can rearrange the function in such a way that it become easy for me to operate, deal with. So to eliminate the cubic root, I can decide to find the cube here and the cube here, and this cube will cancel this one. In that case, we are going to get something like, okay, x to be equal to what, y what, cube. Yes, this is what we are going to get. So after getting this, we have our next function, which is quite straightforward, right? That is y equal to x over what, 4, right? So in this case, we can also make x the subject to get x to be equal to what, 4y. So now we have all our functions in terms of what, y. And in this same way, it will help us to kind of find the limit of integration, because here now we are revolving above the y-axis, and therefore our limit of integration is supposed to be on the y-axis. So based on that, what do we do? As I was saying earlier on, find the meeting point of these two functions. So what we're going to, since x is equal to x, then you have to go ahead and equate the two functions. So we can say that, okay, now our y power 3 is equal to 4 what, y, right? So when you have y power 3 equal to 4y, we can bring all of them in one side, that we get y power 3 minus 4y should be equal to 0. We can bring y out, which is common. Now we are going to get y squared minus 4 or equal to 0. Therefore, we will know that they will meet at y equal to 0. And they will also meet at y squared minus 4 equal to 0. So for this one, we are going to get y squared equal to what, 4, and we can find square root of both sides, right? And when you find square root of both sides, we are going to get something like, okay, y to be equal to what, plus or minus what, 2. But here we are not going to consider the negative 2. Right, we are not going to consider negative 2, and I explained the reason why we are not going to consider negative 2 with you in my previous tutorial, right, or the other example that we solved. So in that case, we are going to consider the meeting point to be what, y equal to what, 2, because we are focusing on the positive sides, right? We are focusing on what, the positive what, sides. So based on that, what do we do? Now we know that our meeting points will be from 0 and what, 2. So based on that, let's quickly do a hand sketch of the information or the graph the graph of the two functions. So now I'll draw my y-axis and I also draw my x-axis here. You can decide to even label this one to be y and then even x over here, right? So when you label this way, now we have to revolve it around the y-axis. In this case, not the x-axis. So what do we do? Let's sketch it first. So in doing this, right, the same thing, the turning points will also be around kind of the turning point will be around kind of 0 as well, right? Because when I find the differential and equal to 0, I'll get 0. Is that okay? And based on that, because the cubic roots, right, is not going to be like the way the square is, I can even factorize y out and y squared, right? And I know that it will be in that shape. But what I have to do is to be something like this, something small, like it will go a little bit up like this, right? Yes. Let me get very good, like, let me put it this way. Yes. Yeah, I'll show you the actual, like the one that we have used software to do, so that you can actually have a good visual to this function. But this is a simple hand sketch, and don't forget that it's not drawn to scale, and this is going to help you towards kind of solve the question. So based on this, we know that we have y equal to x, and we know that the gradient here, y equal to let's say 4x, the gradient is 1 over 4, right? In that case, it has a positive gradient, so it looks something like this, right? So if it looks something like this, what do we do again? The next thing, we know that this one is 0, and then our y value, the next meeting point of the y value is what? 2. If we are revolving around the x-axis, then we have to find the x value at the meeting point so that we can indicate it here. In this case, we don't need it, so that's what we do. So let's move straight to the point and then do what we want to do. Now we revolve it around what? The y-axis. That therefore it's going to be like this. We know that after revolution it's going to be like this, and then let me put this one here. Yes, don't forget that it's symmetrical, right? It's symmetrical about the axis of rotation or axis of revolution. So now I have something like this. So now this becomes what? My figure. Let me put it here, right? This becomes my solid. Is that okay? That becomes what? My solid. And I'll show you, as you can see, that is what I said I will show you the 3D one that we use software to do. And as you can see, this is the 3D part. This is the shape that you're supposed to get, right? Yeah, as you can see on the screen, that is 3D shape that you're supposed to get. So let's quickly come back to our main screen and then look at what we are doing. So now that we have this simple sketch, the next thing is to what? Find the outer function and the inner function, because we are going to find the inner radius and the outer radius. So in this case, our inner radius will be this, with this, and it should be up to this point, but here will be the complete one will be diameter, but the radius will be this at any point in time, right? Yes, or this one, the other side as well, doesn't matter. And then the outer radius, you can see that the diameter is the complete one from here to here, but the radius will be from this side to this side. Is that okay? So that's what I was talking about. And in this case, we have to make the function in terms of what? Y, right? And we have already done that over here. When we were revolving around the what? X-axis, the function needed to be in terms of x, but here, since we are revolving it along the y-axis, and then the limit is in terms of y as well, the function is supposed to be in terms of y. And we have already done that, as you can see over here. So now that we have the functions in terms of y, then we can use that to find our radius. So how do we find the radius? I told you earlier on that to find the radius, now our outer function becomes this. Let's say capital R. That is capital R for the radius, and then the inner function small r for the radius. So in that case, our outer function AO will have an area of what? Pi capital R squared, and in that case the radius for the outer function, which is what, x, y equal to x over 4, or let's say x equal to 4y, is going to be pi, and then we get what, 4y squared. That's give us what, 16 pi y squared. This is what we have. And then the next thing that we have to do is to find the radius, the area of what, the inner function, that is a in, supposed to be pi small r squared, and in that case we are supposed to get something like, okay, pi, and then the r, the function is what, x power 3, right? So since it's y power 3, so since it's y power 3, then we put it y power 3 all squared, and that gives us what, pi y power 6. So in that case we can go ahead and say, okay, our volume, which is what, v, is equal to, right, our volume v is equal to the integral of the area, let's say integral of a b, the area a naught minus a what, in, and then all respect to the function, and in this case we are integrating with respect to y, right? So in that case we have v equal to integral of the limit of integration. When it come back, we can say it's from 0 to what, 2, and therefore we can say, okay, 0 to 2 on the y-axis, and then we know that a naught is equal to what, 16 pi y what squared. Our a naught is what, 16 pi y squared, right? And then the next one is minus our a in is what, pi y power 6, that is pi y power 6, right? And then dy. So because pi is common in this case, we can decide to bring what, pi out. So if we decide to bring pi out, we are going to get the volume to be equal to pi out here, integral of 0 to 2 of what, 16 y power 2 minus what, pi, let's say pi has already been factored out, so minus y power 6. So now this is what we have, and all dy. So now we will continue to do what, the integration. So in doing the integration, we have what, v to be equal to pi out here, and then when we do the integration, we have what, 16 y power 3 over half 3 minus y power what, 7 over 7, and now we have what, something like the limit of integration to be 0 to 2, right? So now that we have this, we can still go ahead and simplify things. So pi out, and then we know that for the 0 part everything will go to 0, so we don't have to even bother ourselves with that. So let's quickly simplify the 2. So we have 16 and then 2 to the power what, 3 over 3. So let me write it here, right? And then minus, we have 2 to the power 7 over what, 7. And when we have point this one into calculator, so we are going to get something like 1v equal to pi out 128 divided by 3 minus 128 over 7. And then with these two, we can go ahead and then simplify things, and that gives us 24.38, and then multiply by pi, and we can decide to confirm from here at multiply by pi, then we get 76.595 as our final answer. 76.595 as our final. So this is actually what we will get when we get here, when we get to this point, and then we decide to kind of do the evaluation. this is the final answer that we are going to get. You can also leave it in pi or in a fraction form, multiply by the pi. Any of them will be accepted, right? Sure. So this is how we do it if you want to kind of revolve it around what the y-axis instead of x-axis. So thank you for watching and see you in my next video.